Welcome to Cosmic Compass, where we journey through the wonders of the universe together. Here we explore planets, stars, and the hidden stories of the cosmos, guiding you through the mysteries that lie beyond our world. Today, let's turn our gaze to the far reaches of the solar system, where a tiny icy heart beats at the edge of the Kuiper Belt, Pluto. This is Pluto, a tiny and mysterious world on the outer edge of our solar system. From Earth, it appears no brighter than a faint star. But up close it reveals a landscape unlike anything we have ever seen: towering ice mountains, nitrogen glaciers, and vast canyons winding through its frozen surface. Despite its grandeur, Pluto is incredibly small, much smaller than our moon. Yet it is strikingly colourful, with shades ranging from bright white and rusty red to deep black. Among celestial bodies, only Saturn's moon Iapetus rivals its contrast. Until recently, though, Pluto was nothing more than a blurry patch through even our most powerful telescopes. Nearly 5 billion kilometres away, this dwarf planet seemed forever out of reach. But everything changed in 2015. NASA's New Horizons spacecraft became the first to visit Pluto, sending back breathtaking images that transformed a distant dot into a vivid world. Those pictures did more than satisfy curiosity. They raised new questions. What shaped this icy heart of the solar system? Why does such a small and remote body show signs of activity usually reserved for larger worlds? Could Pluto even hold secrets beneath its icy shell that might challenge what we know about life in the cosmos? Today, let's journey back to Pluto together. We'll retrace New Horizons' mission and explore its most astonishing discoveries, from the famous heart-shaped plains to possible hidden oceans and even volcanoes that spew ice instead of fire. By the end, you might never look at Pluto the same way again. New Horizons launched in January 2006 from Cape Canaveral. Its goal was bold: to fly across the solar system and study Pluto along with its moons Charon, Styx, Nix Kerberos, and Hydra. At the time of launch, not all of these moons had even been discovered. For 9 years, the spacecraft raced through the dark. Finally, on July 14th, 2015, it made its closest approach to Pluto. That brief moment, lasting only hours, produced some of the most extraordinary planetary images ever taken. The mission was not without challenges. Given the immense distance, the probe could only transmit data at a trickle, just 1 or 2 kilobytes per second. To put that in perspective, a single image took hours, sometimes days, to reach Earth. It took over 15 months to downlink the entire dataset. Each new picture released by NASA sent waves of excitement across the scientific community. Even now, when we look at those images, the sense of wonder remains undimmed. For the first time, Pluto was no longer a faint smudge on a telescope lens, but a living, dynamic world. And as with any good puzzle, the closer we looked, the more pieces fell into place, but also the more mysteries appeared. Let's begin with some of Pluto's most striking landmarks. Near its equator lies a chain of dark regions called the Brass Knuckles. This collection of 6 lowlands stretches hundreds of kilometers across, each named after spirits from mythology: Krun, Allah, Balrog, Vukub, Kam, Hunkam, and Mengpo. Yes, Tolkien fans, Balrog Macula is a direct nod to the fiery demon of Middle-earth. The dark colour of these areas comes from tholins, organic compounds created when cosmic rays strike methane and nitrogen. Tholins give Pluto its reddish hues and cover many regions, including the vast whale-shaped Cthulhu Macula. Separating the dark lowlands are towering uplands made of water ice capped with nitrogen and methane frost. On Pluto, water ice is as strong as rock, with gravity only 1/15 that of Earth's mountains of solid water, can rise several kilometres high. Meanwhile, nitrogen ice, much softer, tends to flow and pool in the valleys, creating a constantly evolving landscape. But the most iconic feature of Pluto is its giant heart Tombaugh Regio, named after Clyde Tombaugh, who discovered the planet in 1930. This heart-shaped region dominates Pluto's face. Its western lobe, Sputnik Planitia, is a vast, smooth plain of nitrogen ice. By contrast, the eastern lobe is rugged and pitted, resembling the skin of an orange. Scientists believe Pluto's thin winds carry nitrogen from the plain into the atmosphere and deposit it onto the eastern uplands, giving them their bright, icy appearance. In turn, some of that nitrogen slides back down as glaciers flowing into Sputnik Planitia once more. The two halves of Pluto's heart then live in a kind of delicate balance, exchanging material back and forth. Every heart has its secrets, and Pluto's is no exception. Moving west across Sputnik Planitia, we encounter the El Idrisi Montes, a dramatic range of icy mountains. Here, Pluto reveals yet another surprise: vast dunes made not of sand, but of methane ice. At first glance, dunes on Pluto seem impossible. Its atmosphere is so thin that winds should barely stir the surface. Yet New Horizons revealed a field of rippling ridges resembling deserts on Earth, such as the Taklamakan or Death Valley. How did they form? The process begins with nitrogen ice. As sunlight strikes the plains, nitrogen sublimates, changing directly from solid to gas. This powerful phase change lifts tiny methane particles into the atmosphere. Winds then push these particles toward the mountains, where they settle and form dunes stretching for thousands of square kilometers. Imagine standing there. The dunes would feel like dust slipping through your fingers, except they are frozen grains of methane shifting under temperatures of minus 230 degrees Celsius. It's a reminder that even in the most hostile corners of the solar system, nature finds ways to sculpt beauty. Perhaps Pluto's most astonishing revelation is what lies beneath. Evidence suggests the dwarf planet may once have harboured and could still host a vast subsurface ocean. At first, this idea seems impossible. How could a world so small, so far from the sun, maintain liquid water? Yet subtle clues point in that direction. The uplift of mountain ranges, the formation of trenches, and the flow of ice suggest internal activity driven by more than just surface processes. The key lies in Pluto's interior. Although its rocky core is smaller than Earth's moon, radioactive decay within it may generate enough heat to keep water from freezing solid. This ocean, if it exists, would be trapped beneath a thick shell of ice. If true, Pluto joins an intriguing family of ocean worlds' moons like Europa, Enceladus, and Ganymede, and with oceans comes possibility. Where there is liquid water, scientists inevitably ask, could there also be life? We cannot yet answer that question, but the very fact that a body as small as Pluto could harbour such complexity changes how we view the outer solar system. It tells us that even the most unlikely worlds may surprise us, hiding dynamic processes beneath their frozen exteriors. The surface of Pluto holds another surprise possible: cryovolcanoes. Unlike volcanoes on Earth, which erupt molten rock, these would spew ice and water. One of the most prominent candidates is Right Mons, a towering structure made mostly of water ice. Rising 4 kilometers tall with a massive central depression, it looks strikingly like a volcanic caldera. The surrounding terrain is unusually free of impact craters, suggesting that it may have been active in the geologically recent past. Nearby stands Picard Mons, even larger at 7 kilometers high. Although captured only in partial shadow, it too bears the hallmarks of a giant cryovolcano. Both features contain vast sunken centres with concentric rings hinting at repeated eruptions and collapses. If these are indeed cryovolcanoes, they provide further evidence that Pluto is not a dead world. Instead, it may still be geologically active, reshaping itself even today. Imagine a landscape where mountains don't blaze with fire, but breathe out icy slurries into the cold air. That is the strange paradox of Pluto. Pluto was once thought of as little more than an icy rock on the fringes of the solar system. New Horizons shattered that image, revealing a place of startling beauty and complexity. From the dark stretches of the brass knuckles to the shining plains of Tombaugh Regio, from dunes of methane to mountains that may conceal an ocean beneath the ice, Pluto is alive with mystery. Its possible cryovolcanoes remind us that even small worlds can be dynamic and unpredictable. As we look back, one question lingers: what else might Pluto be hiding? Could life exist in its hidden ocean? Will future missions return to the Kuiper Belt, perhaps to explore Eris or other dwarf planets? Reaching them will take decades, but the rewards could be extraordinary. For now, we have the remarkable images. New Horizons gave us snapshots of a world that continues to defy expectations. And as we piece together Pluto's story, we are reminded that exploration is never truly finished. The cosmos still holds countless secrets waiting for us to uncover. So next time you see Pluto in the night sky, or imagine it faint and distant, remember, even the smallest worlds can hold the biggest surprises. Thank you for watching Cosmic Compass. If you enjoyed this exploration, join us again as we uncover more of the universe's hidden stories. Don't forget to subscribe, and let's keep traveling together through the stars. Until next time, keep looking up, because the cosmos always has more to share.